So guys, what was the concept that we are discussing? Production and content. So what we discussed in the last class, you tell me. Like we discussed about processing. What is a processor, guys? Normally you tell me. You see here, what is a processor? I clearly told you like CPU will be there. Like for example, best examples I told you here. Suppose if you are selecting two different functions, and if you run the code, your main CPU will be there. No, so your main CPU will execute the first function. After completing the first function only, then it will go to the second function. After completing the first function only, it will go to the second function. Yes or no? So this is with one CPU. So to overcome this issue, what we have done? Multi-processing. How many CPUs we created, guys? You tell me. How many CPUs we created basically? This also in this IDLE mainly. In the online IDLE, this is not so perfect. So for this section, to understand this concept, what I will do is I will use the VS Code or PyCharm because so this processors now, so it's connected to the server, so it won't work properly. Now what I'm going to do is simply I will open same coding will be same, just doing in different ideally just for this concept. Okay, if not understanding, let me know. So in the desk, I'm going to open my VS Code, another ideally simply that is nothing but an another ideally. So I'm going to open that one. Processing. Okay, so here what I'm going to do is, see, listen very carefully. We spend some time also, no problem, but the concept should be very clear. Don't worry, you just copy paste the code and you run here only. But for explanation purpose, to understand in a very detailed way, I will use the IDLE. Okay, I will use the IDLE. So the point here is, okay, right, see, coding will be same. Whatever the code that I'm writing, I will write here. So let's do one thing, guys. So, guys, you tell me simply. I will tell you the concept. Listen very carefully. First, I am going to teach you. First, I am going to teach you properly multi-processing. Okay, multi-processing. Guys, I will write. I will write one code in front of you. You need to tell me what happens. Okay, multi-processing. First, I will tell you. First, I will tell you multi-processing. Listen. First, I will write a code. You come here. Already the code is there, which we have done this one. I will copy the code. I will paste it. I hope everyone practiced. Okay, guys, you see what I am doing? What I am doing here? I am creating. See, very simple. The graphs also I will do. First, I am creating two functions. What is the this is first function. This is second function. So this is, what is this function name, guys? India. What is this function name? India. What is the second one? USA. Okay, two functions. So guys, I am using the main CPU, or I am creating a sub CPUs here? Tell me. Am I using the same CPU or a single CPU, or I am creating the CPUs here?
Sub
Tell me.
CPU, sir. Two
There is a
CPUs process.
There is I am creating two functions and I am going to run with main CPU only.
No,
Nowhere I
sir,
am
not
creating.
yet created. Processing process not yet created, sir.
Yes. So main CPU. It's a main CPU. So what I am telling, see here, two functions are line by line execution. Python is a line by line execution. I already told you. So go to the search option or sticky. So see, here what I'm going to do is, let's say for example, main CPU. This is main CPU. Okay. Now what I am doing here is one function is the first I am recording the time. First I am recording the time. Okay. One function I created. Okay. It will take some time to create another function sometime. And what I'm telling the CPU to call this particular function. So after see, it is calling this particular function, which means it will go inside and it will execute the loop. And for every iteration, I am holding for 5 seconds. You can ask me, sir, it is holding for 5 seconds. No. So US function will run. How it will run? After completing the India function only, the CPU will look into the USA function because of line by line execution. I'm telling you, because of line by line execution. So here also, if you observe properly, I am calling India, going inside the India. It will take some time because you are keeping some timer. So it will take some time. Okay. After completing this, what happens? After completing that, next, we are going to call the USA function. See, USA function will be called, and this also the loops will iterate, and this will also take some time. This will also take some time. Once completing this one, then only it goes to the next one. After completing this one only, it goes to the next one. So first I'm recording the time, last also I'm recording the time. The last time minus first time is nothing but the actual time, how much time it takes. Because 2 o'clock I went to movie and 4 o'clock I am coming back. 4 minus 3 is nothing but 2 hours I am spending the time on the movie. Okay, main CPU after completing the one function, then only it will go to the next function. Remember this point. Lot of people will think, sir, here 5 nanoseconds, this function is holding. No, so CPU will go. No, it's not possible directly. The main CPU is executing, so that is not possible. See, I'm going to save the code here. If I do it in the VS Code or PyCharm, you will get more information. I mean, you will get exact results. So when compared to the online IDLs, when compared to the online IDLs, let's say for example, where is that one? Where is the code I have done? Okay, I'm going to here. Guys, what is the file name? Multiprocessing, you know. The coding file name is multiprocess. I'm going to run this code. See, I'm going to run this code. Oh, don't worry. In upcoming sections, we will work with the VS Code also. Don't worry in that. Okay, I'm going to open my command prompt. See, in the location, in the downloads, in the processing, I'm going to run this multiprocessing file because in that particular file only I'm having the code. Okay, so Python multiprocessing, and if I'm running, say first CPU is running India function only, then only it is running USA function, then only it is running USA function. Total 10 seconds it collected, total 10 seconds. So this is normal way of coding. This is normal way. I'm going to rename the file also. This is not a multiprocessing, normal coding. Okay, or else if you want to get better idea, let's write like main processor. Okay. Main, the file name I'm writing as main processor. So here, let me rechange and let me write here. You see, same. I just change the file name. Main CPU is running the code. So once completing first function only, it will execute the second function. Say 10 seconds. Okay, now see, I'm going to create another file which is known as an multiprocessing.py. Okay, multiprocessing.py. For that also, okay, I will write the code from the scratch. You be ready. Okay, guys, this is main CPU. You can help me, like if you know the concept, if you work on this last day or yesterday or last classes. So guys, you tell me this is what main CPU. For example, what I'm saying is, let's say this is main CPU. For example, main CPU. So from the main CPU, I am making two more CPUs. I am making two more CPUs. Copies. Okay, copies. Copies I am doing. Two more CPUs I am making. So this is I am naming as C1 and I am naming as C2. So from the main CPU, I am making a copy C1 and C2. Okay. Yes, can we write the code for that? So see, multiprocessing, which means creating multiple processes and okay. So see guys, how to write the main one? You tell me in the last class I told you how to write the main processor. Forgot it. How to write the main CPU, main
If
processor.
Underscore
Yes.
underscore main,
if
sir.
name
If
With name.
underscore
underscore
name double equals to
name underscore double is equal to underscore main.
yes. So this is what this refers main CPU. So in the so I'm telling like in the main CPU, like you need to inform the main CPU, na? Without informing the main CPU, how can you okay? Without informing the main CPU, how can you create? I'm asking like how can you create the sub CPUs? Let's say for example, you want me to teach in the afternoon, in the morning, in the evening, at a time. You got my point. Let's say morning 7 o'clock I want to teach in Hyderabad. Same morning 7 o'clock you are expecting me in Bangalore. Same morning 7 o'clock you are expecting me in some Chennai or some other location. How it is possible? So I will be in Hyderabad. The original one will be in Hyderabad. My copies will be in Chennai and Bangalore. But if you want to do it, first of all, you need to take the permission of me. Yes or no? So that what I'm going to do? First main CPU. So I'm telling the main CPU. So which means inside the main CPU, I'm going to create C1 sub CPU. I'm going to create a C1. How to create, guys? What is the library? What is the library for multiprocessing?
Multi-processing, sir. Dot
Import
process.
multiprocessing.
Multi small processing or capital processing. I will need
Small
Small,
small
sir.
processing.
Small.
Yes. So in the multiprocessing library, there is a function called what is the function?
process.
Process. Yes or no? This is a library. In the library function, like math is the library. Inside that particular library, we are going to have inside that particular library, we are having suppose math library is there. Inside the math library, we are having add, subtract, lot of functions are there. In the same way, now also inside the library, inside the multi-processing library, we are having a function called process, which is used to create the clone of a CPU, which is used to create the clone of a CPU. So see here, uh, so this particular CPU, what it should target? It should target which function? India
India function.
function. So already India function is here. I'm going to take the India function and I'm going to keep it here. Okay. So my CPU one should target India function. And are you passing any arguments, guys? I mean, are you passing any? What is the meaning of passing? For example, if you call the function, if you pass 10 comma 20, you need to accept here no with a comma b or something like that. So like that, I am asking, are you passing anything to the India function? No, I am not passing anything. Simply I am calling see if you use this idealist, it will be super real-time idealist. I am going to click on the India. See, it is routing. See, it is routing. So CPU1 is targeting India function. Inside the India function, what I have written 10 times I need to iterate the loop. First time when I am iterating, I need to wait for 5 nanoseconds. Then again, second time, I need to wait for 5 nanoseconds. Again, third time I need to wait for 5 nanoseconds. So this CPU will run the India function. Okay. I hope everyone this understood now, guys. Time dot sleep. Time is the library. In the library, there is a function called sleep function. What it will do, it will just hold for how many seconds that you are passing. How many nanoseconds? What is the second CPU that I am going to create? I mean, main CPU. From the main CPU C1 I created. What is the next one? C2. What is the target, guys?
USA.
Okay.
USA.
Target is USA. Are you passing any arguments? No, I'm not
No,
passing any arguments. Okay, done. So C2 is starting. C2 is starting USA. Now see, one CPU means after completing one function only, it will go to the next function. But here what I am doing, if you observe, I'm creating two CPUs. Now I will tell the CPU1 to run, CPU2 to run. This CPU continuously it will execute the India. This CPU continuously execute the USA. So because two different CPUs, you got my point, guys? Yes or no? Now my question is, see, there are two different options. If you want to make sure, sir, CPU1 is running, CPU2 is running, CPU2 is running USA function, CPU1 is running UK India function simultaneously. This will run simultaneously. Two different CPUs, na? They will run simultaneously. But if you want, like, sir, I want to make sure that why main CPU is here, because main CPU, from the main CPU I created C1, I created C2, done. CPU1 is doing CPU its own work, CPU2 is doing its own work. Then this main CPU can leave from here, no? Yes or no? I can use the main CPU for some other purpose. Am I right or wrong? You tell me. You got my point, guys? For example, there is a house. For example, there is a house, a construction house. Owner is there. Owner bring two servants with him. Two servants. So he is the owner. So owner given the work for this particular person and this particular person. Okay, he is doing his work. So owner should be there or not. It's his own option, yes or no? If you want to wait till the work complete, he can wait, or else he can go outside and he can do some other work. Yes or no? Am I right or wrong?
Yes, sir.
Okay, so whether to make sure that you will hold the main CPU here or whether you will use the main CPU for some other purpose, it's your wish. For example, I'm constructing my own house. I bring two labor people, the people who are working. They came to my house. I have allocated some work. So I told one of the person to do some fencing kind of work and some plastering kind of work, and some other person I told to make the interior. So they are doing their work. I will go out. I will eat some food. I will do my job. I will talk with my manager. I will talk with my colleagues, and I will come back in the evening. What happens? I can do my work now. Why sitting there only and watching? If you want to wait, you wait. That's your wish. But there is a possibility, yes or no. So see here, main CPU created two CPUs. Okay, two CPUs it is created, and you are targeting CPU1 is targeting India function, CPU2 is targeting USA function. Okay, this is done. Now, guys, if I run the code, it will run. Will I get any outcome?
No, sir, we want to join.
No join. That is the mistake here in this idea. Now I will tell you. You created the CPUs. CPU1 you are targeting India. CPU2 you are targeting USA. Did you started the CPUs? You tell me. Did you started these two CPUs? You haven't started.
No, sir, not yet started. Now we want to start.
See, C1 dot start. C2 dot start. Now C1 will start executing India function simultaneously. C2 will start executing USA function. Now, if you want to make sure that main processor should be here only, it should not go outside. It should be here only. Means don't you give join. You give join. If you don't give join, means what happens? If you don't give join means CPU1 will start working, CPU2 will start working, main processor will go outside because two CPUs they are doing their work. What is the purpose of main CPU? I will use for some other purpose. So how to do it? See, I will write here. I include in the time also I will tell you. Okay. First, first I'm finding the time. I mean, because to do these operations, first I need the time now. I'm collecting the time. What is the time currently? I'm collecting the time. Next, I'm creating two CPUs. I'm telling the CPUs to start. I'm telling the CPUs to start. Here also, I will write here. See, once the time is started, I will write here. I print the condition, I will write. And here also make sure, I will tell you lot of content will be there, guys. See, starting. Main CPU is starting. So main CPU is starting now. Starting time will be recorded. And I'm going to write it. Main processor is CPU. Main processor is started. Main processor is started. Okay. How do you know like it's a main processor? Because main processor is started. Print the ID. Like if you want, you can print the. I told you everything variables also will be having their ID numbers. Okay. So import OS. There is a library called operating system. So see OS dot get processor ID. PID means processor ID. So first main CPU is starting. First main CPU is starting. So you are recording the time because to do this all the operation, how much time you need to record? No. So what I am doing here is first main CPU is starting time I am recording, and I am printing this main CPU ID number. ID number also I am printing here. See, I am printing. I am creating the C1. I am creating the C2. Okay. What I'm doing? I'm creating the C1 and I'm creating the C2. Okay, I created the C1. I created the C2. That is all. Let me erase all this properly. Yeah, guys. Now see. Now you see. The point here is first main CPU. I went to the main CPU. I recorded the time. I will write here very clearly. First I recorded the time because it's just starting stage. No. First I recorded the time. After that, what I am doing? I am finding this ID number. What is the ID of the main CPU? See, main processor is started and its ID number and its IDC. I will add. I told the print conditions also. Yes or no, guys? You can write in between the quotes whatever you want. It will print in front of you. Along with that, you can add the variable also with the flower bracket. I told or not? And ID. So exactly it will print as it is. And inside the variable, inside the flower bracket, you will get one number. So it is inside the flower bracket now. The number will be printed in front of you. You just see the print condition concept. I told all these things. Okay. Next, what is happening? It will print the ID number of the main processor, main CPU. Next, C1 is created, C2 is created. You are telling the C1 to start. So if you are telling the C1 to start, when it will start India. But here what I will do is see here also C1 is running India, no. So let me also print the ID number of the C1 because let me see like three are different because to three different CPUs now we need to check whether there are different one or same one. See C1 ID C1 processor ID. Okay, OS dot get PID get processor ID. Okay, get processor ID. So C1 ID will come. After coming the C1 ID, the for loop will run for waiting every 5 seconds. I mean 5 nanoseconds. And C2 also simultaneously it will start executing the USA function. Here also I will write like see here C2 processor ID processor ID. Okay. Okay, C1 processor and C2 processor in printing. Okay. Okay, see, you went to the CPU and you have printing the ID numbers, collecting the time, everything you are doing. My point is, do you want to make sure that you want to wait the main processor? If you want to make sure that you want to make that main processor should wait till the time is to complete the work, means you need to add the join. Now see, first I will do one thing. Guys, for example, you see, I will ask a general question. Imagine starting time. Okay. This print condition will print like main processor ID number. ID number will come. C1 started its working. C1, C2 started its working. After printing all these things, if this print condition is coming, means main processor is waiting for C1 and C2. But C1, C2, once they are starting this work, without completing these two, if you are getting this one, means what does that mean? Main processor is waiting or main processor is going out? Got my point? What I'm saying? First of all, time. You are recording the time. You are printing the processor ID. So you are starting C1 and you are starting C2. After starting C1 and C2, they are still running only. They are still running only. While they are running only, if you see this message, if you see this print, what does that mean? Main processor is waiting for C1 and C2 till they are. I mean, even though when they are running, if this message comes, means main processor is leaving, because C1 started, C2 started, it just left away. Why? Because you see, C1 started, C2 started. If this print condition is happening, means the main processor is leaving from here. C1 and C2 is working on these two functions. Yes or no? But if after completing everything only, if this is the last output, means after completing like C1 completing its work, C2, if you see this print condition at last, means the main processor is waiting. Guys, you understood the code? Tell me, all of you understood the code or not? Total time. Guys, understood? If not understanding, please let me know. Current time minus starting time. I will get the total time. I'm going to save the code and I'm going to that location. I'm going to run that particular file. See, I will run the file. You just see here very clearly. See, I'm going to run that file. Python multi-processing. See guys, see how beauty is it? First main process, main CPU activated. Main CPU is activated. Okay, its ID number is coming. See, ID number is CPU ID number 15436. And see what this CPU has done. CPU simply created C1, C2 and told the C1, C2 to start, and it went away. It went away. It is not waiting till the C1 and C2 complete its work. I have bring to people. I just allocated the work. I went away. I'm not staying till the time they have completed the work. So that is the mean. See, processor created, processor existed, which means internally it's allocated the work for C1 and C2. It went away. It went away. Now see what is happening. Now if you see C1 is starting. Yes or no? C1 is starting. It is going to the C1. So let me do one thing. This make sure. So guys, you see here. Okay, don't worry about this. We can keep the print in the perfect area. So don't worry about it. So see here, the point here is first main CPU. So main CPU is starting. Main CPU started. It created C1 and C2. C1 processor ID is this one. C2 processor ID is one. Three different CPUs. Okay. C1 and CPU. C1 and C2 are running simultaneously. See. So C1 is running India. C2 is running US. So simultaneously, the processors are running. How much time it collected? How much time it is collected? But this is wrong time. This should be somewhere else. But you see, main processor existed, which means main processor will not wait for the C1 and C2 because it allocated the work. It's going out. Simple. It will do some other work. Why it will wait here? If you want, you can make sure that if you want, you can wait. Okay, you need to write that explicitly. You need to write that explicitly. So the point here is why the print is coming. Okay, print by starting time, ending time. Let me do one thing. I can write somewhere else. So this is the issue with. No problem. We need to make sure that we need to wait for the CPU, main CPU, or else we'll get the same issues. Okay. So okay, forget about the time. See, main CPU is leaving, the automatical time is giving. That's a different story. If you see here, the point here is what happened? See, it is running. CPU1 and CPU is running, and main CPU is going away. Main CPU is going away. Guys, you understood this code? Everyone? You understood this code or not? Tell me.
Sir,
Yes, please.
sir, I just want to know about those flower braces and normal braces, the column, where we have to keep those column. Those are really most important, I think so. So, how to get those, sir? Like where we have to open the brace and where we have to close the brace.
It's very simple. For the print condition, print is a built-in function. Built-in functions will be maintained with the parentheses.
Yes, sir. And the
Okay.
column where we have to keep, sir, column you're keeping for definition USA and India, no, sir.
Function, I told now. Inside the function only we will write the code. We'll write the logic. Inside the function only we'll write the logic. The point here is inside or outside. Outside means normally we will write. But see, inside the function, I'm writing the logic. Inside the function, I'm writing the logic. Inside the for loop, I'm writing the logic. And inside the main memory, I'm doing the operation. So inside means keep the colon and go inside.
Okay, sir.
Okay. Now, okay.
So
this is
you're
fine.
saying,
Please go ahead.
you are saying that here in the print function, main processor is exiting, right?
Hmm.
Okay. Thank you.
It is going good.
Sir,
It is just
those like in libraries we'll get to know about those functionalities and all. OS dot get processor ID and all. So
Yes,
there
yes.
we have to keep those braces and all. It is already inbuilt, no, sir. So I think we have to practice more on this, no, sir.
No, very simple. Like see, OS dot you type C get. Suppose type like this. Okay, just type like this. See, you just see here process. This is there or not?
Yes, sir.
So, like if we just check in the internet, for the function parenthesis there means keep. If it's not there in the internet means don't keep. Simple. We can check in the internet. No problem in that.
Okay, sir.
Okay.
And India, after India, you're opening the braces, no, sir. Like for what reason you're opening the braces? Means to pass the arguments because it is an empty argument, so you're not.
Yes, it is empty here. I'm not passing anything here, so it is empty. Let's say why to write 1 comma 11 11 here. You can pass 1 comma 11 here, and you can accept with a comma b. And here we can write a comma b, like parameter function.
Yes,
So,
sir. Then why you did not write, sir?
no, it's what I'm trying to say is if you want to pass, you can pass here. So what I'm trying, simply I have written inside. If you want to pass any arguments, you can pass here. Let's say, for example, for the India function, if you want to send 10, pass 10, okay, pass 10, accept with, for example, A. And if you want to print that, you can print that A every time. Okay, so see, there are two different things. Sometimes we pass, so sometimes we don't pass. Functionalities will not behave like that, okay? Because imagine you are not passing anything. So if you don't write this one, and when you pass anything, if you write this one, what is the proper syntax of the function? So there don't be two syntaxes. In every concept, one syntax only. So functions, parenthesis will be there. If the user, whenever user is calling the function, where if you want to pass anything, he can pass and he can accept it. If we don't want to pass anything, don't accept anything. Simple.
Okay, sir.
Understood? Yeah. Now, can we make sure that can we hold the main CPU till the time C1 and C2 gets complete? Yes. So C1 is requesting, C1 is requesting and C2 is requesting. So main processor is creating two things and allocating the work. And C1 is starting, C2 starting, and C1 is telling, hey main processor, please stay till I complete. And because two people who came to my home to work, they're requesting me to wait. So the main processor will wait until the time it completed, till the time C1 and C2 gets completed. You can see here. So now see, you can see here. See the outcomes. See first, main processor started. It created two CPUs, C1 processor ID, C2 processor ID. C1, C2 is running simultaneously. C1, C2 is running simultaneously. Total time 5 seconds. It's collected 5 milliseconds, something like that. And after completing C1 and C2 only, the main processor going out. After completing the work, okay, after completing the work, after completing the two people who came to my home, after completing their work only, I am going outside the house. Till then I am waiting. So in the real time, make sure that you maintain, sometimes depends on the scenario, you will maintain the processes to be waited. Sometimes you want to maintain the processes, sometimes you won't maintain the process to be waited, you will use for some other task. Guys, understood? Multi-processing, very, very, very important, I'm telling you. You understood what is a just start, what is join, everything. Suppose in sometimes your manager will tell you, Kamal, continuously the application is running. Please kill the processor. Please kill the processor. Immediately what I will do, I want to kill the processor. See, I will kill the processor. Kill means it will stop. Okay. Kamal, please terminate that C2. Like terminate means it's not going to kill, but it is going to be struck. I mean, it just wait, struck. So terminate will be there. So different functions. Okay, like you can play with the CPUs here. Okay. For example, in whatever the work that we are doing, general in any company, I am
Sir,
a CV engineer. Yes.
if we killing the processor means can we lose the data also, sir?
Data what? You are not giving any data now here. You are telling to execute. You are giving the work only. So
Okay.
if, for example, you are telling the CPU C1 to kill means it will go there, like a C1 will be deleted. That particular CPU will be deleted. Whatever the work that is assigned for the C1 will be not done. They will be in the hold. Okay. So in the real time, one of the example I will tell you. Let's say as a CV engineer, daily what I will do. So currently I'm working for airports. I think most of the people might know for the projects. Next 4 years, same projects only. So around the airports, how many cameras will be there? Lot of cameras. Total, I'm working with 186 cameras. So 186 cameras, for example, let's take a few. I'm going to write off 5 or 10. Each one is a camera. For example, camera 1, camera 2, camera 3, camera 4, camera 5, camera 6, camera 7, camera 8, and camera 9, and camera, 10 cameras are there, for example. If I take the continuously feed, which means the input, the video input from the camera one all the 10 cameras, camera in videos, if I take on a single CPU, it won't work properly. So what I will do? So I will tell the main processor to create 10 CPUs. C1. So C1 will take care. One CPU will take care of camera one. C2, another CPU will take care of camera 2. So another CPU will take care of camera 3. So another CPU will take care of camera 4. Why, sir? Why you are using? See, if I don't use this one, after completing the C1 video, C2 will run. After completing C2, C3 will run. How it is possible to maintain the application? It is not possible. So what I will do? I will create 10 CPUs. 10 CPUs I will create. So each CPU one camera continuously, simultaneously at a time they will work. Yes or no, guys? You tell me. Which one is the best option? Giving everything to one CPU means, see, for camera one is coming. After 2 hours, camera one completement, camera two will come. Then camera three. So how it is not possible. At a time, everything will come. Na? All the cameras will be running at a time. So what I am going to do here, I am going to use the no multiprocessing, no real time. I'm telling you, any application, processing and threading is very important. Okay, guys, you tell me like we understood the processing or not? First of all, multiprocessing completely and clearly. Okay, so let me go with the threading now. Thread. So, threading. So, what is the meaning of threading? Okay, what is the meaning of threading? See, guys, I will write a structure here. This is the biggest drawback in Python. Threading is one of the biggest drawback in Python. Okay, so till now in the market, Java, why it is alive? Why it is still giving the competition to Python means just because of this drawback. This drawback one I will tell you here. See, for example, I am having 4 tasks. For example, I am having 4 tasks. So that's a break function. Anywhere you can use it, not to stop the processor, to stop the loops, those kind of things you can use the break. Okay. To stop the processors, you need to kill or terminate those kind of things. Okay, now I will tell you one thing. See, first main CPU. Okay, main CPU. So I will tell the main using the main CPU. I will create CPU and one CPU I will create and another CPU one and two CPUs I will create. Using the main CPU, I will create CPU one and CPU two. For example, if there is only India function, see, listen very carefully. India function, CPU will run India function. If there is UK function means CPU2 will run the UK function. That's okay. That's good, everything. Because CPU1 and CPU2 will run simultaneously. But see here, this we have already seen now. Now what I'm going to do is, there are 2 functions. One is Canada function, and one is India function. Okay. And one is Australia function, and another one is USA function. Okay. So main CPU is there now. I am telling the main CPU, using the main CPU created 2 different CPUs. So I am telling the CPU1 to run the Canada function, and I am telling the CPU to run the India function. I am telling the CPU2 to run the Australia function, and I am telling the CPU to run USA function. Now what happens is, see guys, in Python the most important point here is, let's say CPU1, see, processors, listen my words very carefully. Very carefully you need to listen to me. Okay. Processors will run, processes will run simultaneously. Processor means CPUs. Threads, threads in Python. See, processes will run simultaneously. Threads in Python, I'm telling you, threads in Python will run one after other, one after other. So biggest drawback in Python. That's why the Java is still running in the market. I will tell you the see what happens is two CPUs I created. I'm telling the CPU one to run the Canada, CPU two to run India. So what happens is CPU one will run the Canada. After completing the Canada only, it will run the India. After completing the Australia only, it will run the USA. One after other. One after other. I'm telling you. Okay. One after other. But you can ask me, sir, then what is the use? Then what is the use? Here, processes are running at a time. No, got my point. Processes are running at a time. Threads will delay little bit. So thread means I will tell you here. See, I will create a thread. For thread means I will create a thread T1. I will tell the thread to run Canada. I will create a thread. I will create a thread. I will tell to run C2. So thread 1 will run Canada, thread 2 will run India. So after completing the thread 1 only, the thread 2 will start. Okay, CPU will run one function. After completing one function only, it will run the other function. But here simultaneously, they will work at a time. The processes will run at a time, but internal function will be running one after other. In Java, processes will run at a time. Even the threads also will run at a time. Imagine how much fast the applications will be. That's why full stack Java is giving a high competitions till now for the artificial intelligence. I mean data science and data analyst. But don't worry, this Python people, the Python in the documentation, we can see the Python community has given the project to the Facebook company. Okay, Facebook company, and the time is 3 years in the till 2018. They have clearly mentioned in their in their official sites also. So the Python has been given to the Facebook company. Now the Facebook team is working on Python. So in the 3 years, they are going to change everything in Python, and they are going to make sure that threads also will run parallelly, simultaneously. If this happens in Python, threads also work simultaneously means that will be the end of Java. Just because of this only Java is ruling. Java is working till now. If this overtakes means everyone will use Python only. Okay, this is what thread. Thread means is nothing but thread will run a function. Thread will run a function. You can ask me, sir, directly we can run. No. Direct. See, here is the logic. Here is the law. You need to ask me, sir, why you are creating thread here? What is the purpose of thread? What is the purpose? Don't create the thread here, please. Don't create the thread. As you mentioned, like CPU1, CPU2, two CPUs, two different functions. Now tell me guys what happens. Now tell me, CPUs will run simultaneously, but CPU1, after completing the Canada only, it will run the India. Yes or no? CPU2, after completing the Australia only, it will run the USA. Guys, you understood till here? This concept you understood? No thread. As of now, no thread. Keep the thread aside. You understood this point, first of all? Okay.
Yes.
Now see what I'm going to do is I'm going to copy this code and I'm going to paste it here. Paste it here. So see, starting time, so operating system. Let's say main CPU. In the main CPU, two sub CPUs, C1 and C2 I'm creating. C1 I'm targeting to India, and okay, let's create two more functions. Let's create def Canada. Okay, def Canada. So you can see same. Can see here
Sir,
same copy. Yes, please.
sir, here in threading we can use multi-processing so that simultaneously it can run. No, sir.
Come again.
I mean, those two topics are different. Means I'm sorry for that, but I don't know whether we can use that in this. or not, sir? In threading, we can use multiprocessing so that previously you told, no, sir,
From
it
the
will run.
processor, threads will come. From the threads, processors won't come.
Okay, okay, sir.
Okay, got my point?
Okay, sir.
So see here, let's see. Code is same, but in the print conditions I'm changing. One India function is there, one Canada function is there, which is running by the C1. See, C1 is running India function. Okay, C1 is running India function. Listen to my points very carefully. C1 is running the India function, which means this. After completing the India function, you need to run the Canada function. Then where you will write? So that is not the point here. See, again, I will create one function here. Def, uh, C1 common function. Okay, C1 common function I will create. And for the C1, what I will do is C1 common function India Canada. Okay. Now see what I'm telling here is I'm telling C1 common function. Okay, C1 common function. Now in the design, I will do small change. First, let me do only for C1. Then you'll get a clear idea. Like if you keep everything at a time. So I created a CP1. For the CP1, what I'm telling to target. I'm telling to target a function which is known as a C1 common function. Okay, C1 common function. So let me remove this C2. Okay. Now see, I created the C1. I'm telling the C1 to target this function. Which one? This also let me remove this also. So I'm telling the C1 to target common function. So it will go here. Inside what I'm doing? So inside this function, what I'm doing? I'm telling to run India. Okay. I'm telling to run India. So it will go here. It will run entire India. For every iteration, it is waiting 5 nanoseconds. After completing India only, the Canada will come. Yes or no? After completing India only, it will come to the next line. Canada will be called, then Canada function will be called. Okay. So if you see here from a processor, I created a processor and I'm telling to run this function. In that function, I told to run India and Canada. After completing India only, till that time it will wait because see, this is normal CPU only. CPU what it will do? CPU after completing one function only. See, even though sleep is coming, means you are keeping the sleep means it will wait. Okay, after completing India only, then it goes to the Canada and Canada will run. So now if you just go to the here, if I show you, so let me clear the things. Now if I design in front of you, see Python writing that we see main processor started. See main processor started, child processor started. See here. Okay. See here very clearly. Main processor started. From the main processor, I created C1. So I'm telling the C1 to runs a common function. In the common function, what I have written to run the India function. See, after completing the India only, for every iteration, 5 seconds are there, 5 nanoseconds, even though it is waiting. After completing the India only, it will run the Canada. So from here, what you understood? From here, CPU1, even though two functions are there, means one completing this one, it is running this one. Now what I will do to overcome this issue, now what I will do is, I will create a thread 1 for India, thread 2 for Canada. So if you create the thread 1 and thread 2, what happens? See, I will CPU will tell the thread to run India. Okay. In the first iteration, it is waiting for 0.5 seconds. No, immediately what CPU will tell a thread to he is waiting, please run. Okay, it will come. So it will print. When he is waiting, immediately this one will come. So simultaneously at a time they won't work. But whenever it is just waiting for a nanosecond, this one will come. Okay, that is the power of thread. If you don't use the thread inside a processor, see, I'm not using the thread now. What is happening? See, if I am not using the thread, till the time India is completed, I need to wait. Then only Canada will come. Now what I will do? India is waiting for 0.5 nanoseconds. That is enough. Immediately, I will activate the Canada. And when the Canada is waiting for 0.5 nanoseconds, immediately I will activate India. So that is possible with the help of thread only. So that is possible with the help of thread only. That I will show you in front of you. Now come here. So a processor, if it runs directly a function, means it will work one after other. Now what I am doing here is I will come here. So CPU is calling a common function. So in the common function, what I will do is I create the threads. Threading, see, I will create how many threads you want? 2 threads. You want 2 threads. So T1 is equals to threading dot. Just create the thread. Threading dot. I'm going to create a thread. Same. I'm targeting the thread for India, and I'm not going to pass any arguments. Okay. Next. T2. I mean thread 2. I'm going to create a thread dot. I'm going to target USA or Canada, right? Canada. And what are the arguments? Nothing. So see how beauty it is. So CPU is calling this one. Okay. This function is creating T1 for India and T2 for India. If it is not there, means what CPU will do? After completing India only, it will go to the Canada. But now T1, T2. If the T1 waits 1 nanosecond, means T2 will activate. T2 waits 1 nanosecond, means T1 will activate. That short difference will be there if you have the thread. So threads won't work simultaneously like how the processors are working. That is not possible in Python. Threads won't work parallelly, simultaneously in Python. Only processors will work. See, thread 1, please start. Thread 2, please start. Simple. Now see, guys, you understood now what I am saying. First of all, thread and processor connection. Thread and processor connection. For example, let's say I am calling 2 people to do one work in my home. In my home, I'm calling 2 people. So 2 people, one people is doing one work and another person is doing another work. Simultaneously, they are doing the work. But for one of the person, if I give more work, means at a time he can't do. For example, 2 people are there. I will draw a diagram here. So this is my home. Also, I am the owner, for example. So 2 people are there. So this is person 1, this is person 2. Okay, person 1 is doing his own work, person 2 is doing his own work at a time. But if I give more work for the person 1, what person will do? Once completing the first one only, he will do the second work. Yes or no? So thread also same. But if this one is waiting, means this work is waiting, means he will do the second one immediately. Okay, so directly you should not give anything. Directly, if you call the function directly, you need to wait till the India completes. But if I give the thread will take care of everything. Thread will check T1. It is waiting here. See, thread 1 will wait here. Immediately thread 2 will start, thread will run. If the thread 2 is waiting, thread 1 will start. So at a time they won't work, but with a very high speed they will work. See how much time it takes? So much time it takes. Now if I run with the processors, now with the threads, see here, threads are running. Threads are running 2 different functions. Now see 5. Simple. That's what I'm saying. Okay. C1 started, C1 process ready, C1 process ready. So threads are running one after other. So see, first thread T1 is running. First T1 is running. Okay. Whenever the T1 is waiting for 5 nanoseconds, immediately T2 started. Again, it is waiting for 5 nanoseconds, T1 started. So they won't wait 1 minute of time also. They won't waste 1 minute of time. But if you directly write without thread, so after completing India only, it will go to the Canada. So that is the relation between the multi-processing and multi-threading. Processing means the CPUs will work simultaneously. But if every CPU is having the work, means what we will do? Threads. Each thread is capable of doing one particular work. Okay, one particular work. I will tell you one real-time example with short. Imagine this is, say, as I told you, airport. Only 4 cameras are there. Camera 1, camera 2, camera 3, camera 4. Every camera will do a lot of work. For example, camera 4 should detect a person. It should detect a person. It should detect a bike. It should detect a car, for example, car also. So what I will do, I will, from the main processor, I will create 4 CPUs. So CPU 1, CPU 2, CPU 3, and CPU 4. I will tell the CPU 4. So if you just run one function, what is this? I need to detect the person, I need to detect the bus, I need to detect the car. So what I will tell? I will tell like this. So I will tell the CPU 4, hey, you need to detect the person, you need to detect the bus, you need to detect the car. But if you directly write like this, after detecting the person till the one day completes, then it goes to the next function bus. Then it goes to the next function. That is logicless. I will keep T1, T2, 3T. So T1 will detect person, 1 nanosecond gap is enough. T2 will run, 1 nanosecond gap is there. T3. At a time, CPUs will run at a time. CPUs will run at a time. So threads and processors are very, very important. So this is completely about the production level Python, guys. Multi-threading process, multi-processing, how to create the threads, how to execute the functions, how to check the timers, everything. So with this, I can say all the Python, I mean, libraries are different, like NumPy, Pandas, those comes under different Python libraries. But Python concepts like Python, basic Python, intermediate Python, advanced Python, production level, everything is completed. If you have any queries, you can ask me till here. I hope most of the people got. Is it easy concept or a hard concept for you? I mean, asking.
Most confusing concept, sir.
Easy, sir. Easy.
Small logic. This is
అర్థమైనట్టే ఉంటుంది సార్, బట్ కన్ఫ్యూజ్ అవుతుంది కొంచెం.
సార్ వన్ డౌట్ సార్, ఇక్కడ ఈ గెట్ పిట్ గురించి ఒకసారి కొంచెం చెప్పండి సార్.
ఏంటి
గెట్ పిట్ సార్, దీని యూజ్ ఏంటి సార్? గెట్ పిట్
ఓఎస్ అనే ఒక లైబ్రరీలో ఒక ఫంక్షన్ ఉంది. గెట్ పిఐడి అంటే పి అంటే ప్రాసెసర్, ఐడి అంటే ఐడి నెంబర్. ఎవ్రీ హార్డ్వేర్ డివైస్ కి ఒక నెంబర్ ఉంటుంది. ల్యాప్టాప్ ఒక నెంబర్, మదర్ బోర్డుకి ఒక నెంబర్, సిపియుకి ఒక నెంబర్, ర్యామ్ కి ఒక నెంబర్ ఉంటుంది. అలా నా సిపియుకి, నా మెయిన్ సిపియుకి ఉన్న ఐడి నెంబర్ ఏంటి అంటే నాకు ఇక్కడ నుంచి వస్తుంది. నేనేం చేస్తున్నాను, నా మెయిన్ సిపియు నుంచి 2 కొత్త సిపియులు తయారు చేస్తున్నాను. అలాంటప్పుడు వాటికి కూడా ఐడి నెంబర్స్ ఉండాలి కదా. వాటి ఐడి నెంబర్స్ కూడా ప్రింట్ చేసుకుంటున్నాను. అలా ఎందుకు ప్రింట్ చేస్తున్నానని అడగాలి. ప్రింట్ ఎందుకు చేస్తున్నాను, 3 ఒకటే, ఇప్పుడు 3టికి ఒకటే ఐడి నెంబర్లు ఉన్నాయంటే ఆ 3 మెయిన్ సిపియు అన్నట్టే కదా.
అవును సార్. టైం వర్క్ డిఫరెన్స్.
మూడింటికి ఒకటే నెంబర్ ఉందని అర్థం ఏంటి, క్రియేట్ అవ్వట్లేదు. 3 ఒకటే దాని మీద రన్ అవుతున్నాయి, కానీ 3టికి 3 డిఫరెంట్ టైప్ ఐడి నెంబర్స్ వచ్చినాయి అంటే అర్థం ఏంటి, డిఫరెంట్ సిపియూస్ అని అర్థం.
సార్, ఈ థ్రెడ్డింగ్స్ లో మనం ఇన్ కేస్ టైం ఇవ్వకపోతే గనక అది కంప్లీట్ గా 1 after 1 తీసుకుంటుంది కదా సార్?
లేదు, థ్రెడ్ అంటే మీకు అర్థం కావట్లేదు. సిపియూస్ అనేవి మైనర్ నానో సెకండ్స్ వరకు అవుతాయి. ఫర్ ఎగ్జాంపుల్ ఇక్కడ మీరు తీసేసినా గానీ ఇలా లూప్ ఇలా తిరిగి గ్యాప్ లోనే థ్రెడ్కి వెళ్ళిపోయింది మళ్ళీ. ఓకే, జస్ట్ మైనస్ నానో సెకండ్ టైం డిఫరెన్స్ తో ఇక్కడ టైమర్ పెట్టిన కాదు, మీరు టైమర్ తీసేసిన ఇది ఇలా తిరిగి ఇలా వచ్చే గ్యాప్ లోనే ఈ థ్రెడ్ ఇక్కడికి వెళ్ళిపోయింది. ఓకే, సో ఒకటి తర్వాత ఒకటి రన్ అవుతాయి అంటే ఒకటి అయిపోయిన తర్వాత ఒకటి కాదు. సో ఒకటేసారి రన్ అవ్వు.
దీనికి డిఫరెన్స్ అనిపించట్లేదు కదా సార్? అంటే మనం టైం సెట్ చేయబట్టి ఆ గ్యాప్ లో నెక్స్ట్ ఇటరేషన్
మెయిన్ ప్రాసెసర్. ఫర్ ఎగ్జాంపుల్ మీరు ఇంకొక పర్సన్ ఒకటేసారి పని చేయడం అనేది మల్టీ ప్రాసెసింగ్. ఒకటేసారి అట్ ఏ టైం ఇద్దరు కలిసి చేయడం. ఓకే, ఇప్పుడు థ్రెడ్ అంటే ఏంటంటే ఇద్దరు మనుషులు, ఒక పర్సన్ ఆగితే ఇంకొకటి ఆగడం కాదు. ఒక పర్సన్ ఒక చిన్న డిలే వచ్చింది, ఒక మైనర్ డిలే వచ్చిస్తే ఇంకొకటి యాక్టివేట్ అయిపోతున్నాడు. వాడికి ఒక మైనర్ డిలే వస్తే వీడు యాక్టివేట్ అయిపోతున్నాడు. మనం టైం మన పాయింట్ లో చూడకూడదు. సిపియూస్ ఎంత స్పీడ్ గా పనిచేస్తాయి, నానో సెకండ్స్ కూడా తక్కువ లేవు, అంత స్పీడ్ గా ఉంటుంది సిపియు. ఓకే, ఒక మైనర్ డిఫరెన్స్ చాలు దానికి. ఫర్ ఎగ్జాంపుల్ ఇక్కడ చూడండి, మీరు ఇప్పుడు దీనికి కామెంట్ పెట్టండి, దీనికి కామెంట్ పెట్టేసి జస్ట్ కీప్ ద కామెంట్ ఫర్ ద టైం. Now see, thread is there. So go here, clear everything. మైనర్ గ్యాప్ వచ్చిందని తెలిసింది అంటే ఇంకో థ్రెడ్ యాక్టివేట్ అయిపోతుంది. చూడండి ఇక్కడ ఏం జరిగింది ఇప్పుడు ఇక్కడ ఇంత స్పీడ్ గా థ్రెడ్స్ లేకుండా ఇంత స్పీడ్ గా అవుట్కమ్స్ వచ్చినాయా మనకి? ఓకే, థ్రెడ్ 1 ఏం చేసింది, సడన్ గా ఒకటేసారి రన్ చేసేసింది గ్యాప్ ఇవ్వకుండా. సో థ్రెడ్ 2 ఇక్కడ గ్యాప్ ఇచ్చేసాడు, వీడు యాక్టివేట్ అయిపోయాడు. ఓకే, అంటే మీరు రియల్ టైం పర్స్పెక్టివ్ చూడాలి. కెమెరా నుంచి ఫీడ్ కంటిన్యూగా వచ్చేటప్పుడు స్మాల్ 1 నానో సెకండ్ టైం అయిన ఉంటుంది కదా, ఆ టైంలో థ్రెడ్ 1 థ్రెడ్ 2 యాక్టివేట్ చేసుకుంటుంది అట్లా. గాట్ మై పాయింట్ క్లియర్లీ? Clear no guys, everything? So from tomorrow we are planning highly assignments for you. So last assignment questions I will tell in the classes. This weekend you will be getting the update also. And next one, tomorrow we'll start assignments. Every 3 days assignments will be there. And you will be having the exam. Mostly I think Satish will inform you. On 28th of July, you will be having the end-to-end a very good exam on Python. And every 10 days exams are also planning. Offline people can come to office and they can write the exam. Online people can attend in the online mocks also, because Python is important. So from my side, I think I have done everything in the Python. Your side, you need to do practice. Assignments also will do for every 3 days. Okay, for every 3 days we'll do it. Clear now guys? The concepts are clear till here?
Sir, this underscore name underscore equal to underscore main, what is this, sir?
Name, which means name is a function which is targeting the main processor. So underscore name. What name? Main. Main is the name. Main means nothing but main processor. So automatically your Python compilers will activate the main processors, which means main CPU. We call them as main line, I mean main memory, or we can say main processor, like that. Main method, someone will call as a main method.
Okay, sir. Okay.
So still we'll discuss, like what I'm trying to say is till here Python is completed. So we will work more, we'll do assignments, mock interviews more on Python till here. In the classes tomorrow, I will start the libraries. Okay, NumPy, everything will start from tomorrow. Okay guys, this file is available there. If there is any example files, I will add to the drive. Please correct from there and do practice. Catch up tomorrow. Thank you.